Hello, in this video I will explain to you on how to find out V1, which is the voltage across this 60 ohm resistor, and then V2, which is the voltage across this 2 ohm resistor, and then I1 here, which is the current that passed through 5 ohm resistor here. So that is our goal, which is to find out what is V1, and then what is P2, and what is I1, right? So we have three goals here, and we need to use node voltage method. Okay, node voltage method, and we will explain to it step by step. We will do it step by step. So the first step that we need to do is to label all the nodes, right? Label all the nodes. Let's start with our reference node, which is usually the bottommost node here. Let's put it here. So this is called reference node, or some other book call it the ground. And this means that the voltage in this node here, so in this node, the voltage is equal to 0. P is equal to 0. Okay, now let's label the other nodes. We have two nodes here. The first one is this one here. Okay, but remember this is not another node because it is directly connected to this node here. So it is one node here. So let's name this node as node A. So the voltage here will be VA. Good. And the other nodes is this node here. This node is VB. And I think we have no other nodes, right? We only have three nodes. This reference node, node VA, and node VB, right? Okay, and now let's move on to the second step, which is to assume the current's direction. Assumes the current's direction. Okay, for the current direction, for the branch with current source, I just follow the arrow here. This will goes up and eventually it goes to the right, right? Like this. But for this, it is going down. So it starts from this going to the right. Okay, we have already given I1 here. I just follow the direction. So we will have it like this. And then for the other components, it is vertical component. Usually I goes down like this. Okay, but you can assume another direction. The result will be another sign than what is our assumption. But you need to be consistent during the solve. Do not change the direction in the middle of solving, right? Okay, now what can we do next? We need to do KCL for all unknown nodes. Do KCL for all unknown nodes. Okay, in this case, we have two unknown nodes, right? VA and VB. We already know the reference ground, which is 0 here, the voltage there. Okay, so we only need to do two KCL at VA and at VB. Okay, let's do that. Okay, the first KCL that we need to do is KCL at node VA. And what does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Good. Okay, let's see VA here. We have this current that goes in, and it is the only current that goes in. And we know exactly the value, right? Because this is a current source, and the value is this 15 ampere. So we will have 15 here as the only current that goes in. Okay, now let's move on. And then we need to calculate the current that goes out. The first current that goes out is this one here, but we don't know this current yet, so we need to do Ohm's law, right? And how to do that? Remember Ohm's law, the voltage divided by the resistance. And how to calculate the voltage? Let's see the current here. The current comes from VA. Okay, so I will have VA. And then the current goes down into here. And that is the reference node. So I will have VA minus the reference node. That will be 0. Okay, because this is the voltage, we need to divide by the resistance between them, which is 60. Good, and that is the first current that goes out. Okay, the same thing here. Let's see this current here. This is also goes out from VA, right? Because this is directly connected. Look at that. Good. And so we will have VA. VA is where the current comes from, right? Because it comes from this node, which is VA, and then it goes to the reference node. So we will have VA minus 0 divided by 15, right? Okay, now what can we do here is, see here, we have another current that goes out here. So we will have one other current that goes out. Okay, but this is slightly different because the current comes from VA, but then it goes to VB. So I will have VA minus VB, not 0, because it is not going to the reference node. So we will have 3 currents that goes out, right? And it is divided by the resistance between them. So I will have 5. Now we need to get rid of all this denominator here. So I multiplied by 60, which is the multiply of all of this number, right? You can do it by calculating the least common multiplier, which is 60 here in this case. And 15 multiplied by 60 is 900. And then 60 and 60 will cancel each other. So I will have VA minus 0, which is VA. And 15 and 60 will cancel into 4. But 4 multiplied by VA minus 0, that will be 4 VA. Okay, and then 5 and 60 will cancel into 12. So I will have 12 VA minus 12 VB. Good. 1 plus 4 plus 12, that will be 5 plus 12. 5 plus 12 is 17. So we'll have 17 VA minus 12 VB, and that will equal to 900. Good, and I think nothing that we can do from here. Let's save this as equation number 1. Good, and now we need to do another KCL at this node here at VB. Okay, maybe let's clean things a bit. Okay, now for the next step, let's do KCL at VB. KCL, the Kirchhoff current law at VB. And KCL said that the sum of the current that goes in will equal to the sum of the currents that goes out. Okay, let's see here. The only current that goes in is this one here. And that current comes from VA, right? And then that current goes to VB. So we'll have VA minus VB. And we need current, so we divide it by the resistance between them. So I will have 5 ohm here. Good. Now, let's see this current here that is going out. So we will have this VB here. VB is where the current comes from. And it goes to the reference node here, right? So I will have VB minus 0. Divided by the resistance between them, which is 2. And the last current is this current here, because eventually it will close here. We already have the value, which is 5 ampere. So we will have plus 5 here. Okay, what can we do from here? We can multiply both sides here by 10. 5 and 10 will cancel into 2, so we will have 2 VA minus 2 VB, and that will equal to 2 and 10 will cancel into 5, so I will have 5 VB, and we will have 5 multiplied by 10, that will be 50. So we will have 2 VA minus 7 VB, and that will equal to 50, right? So let's save this as equation number 2. Okay, good. So now we have 2 equations and 2 variables. And let's do the next step, which is to solve the equation, right? And we will get the value of VA and VB. Solve the equations. Okay, maybe let's clean up things a bit for getting some space. Okay, now we have 2 equations and 2 variables, and I think the fastest way to do it is by using calculator, right? Because in the circuit analysis exam, you can use your calculator, so why not just use it, right? And how to set this up? So set this up here, we have this button, and equation solver is number 5. And we need 2 variables, which is number 1. Okay, so all we need to do is to plug in the coefficient. So I will have 17 and then minus 12, and then that will equal to 900, and that is the first equation. And the second one, I will have 2 and then minus 7 and then 50. Okay, the x value will be our VA, right? So that will be 60. So we will have VA here is equal to 60 volt. Okay, that is a nice number. And what is VB? VB here is the Y value, which is 10 volt. We will have 10 volt. Okay, now we got our nodal voltage values, VA and VB. But the question does not ask about VA and VB, but V1, V2, and I1. So that is the last step of this problem, which is to answer the questions. Answer the questions. Okay, let's see what can we get from here. Let's see the first one, V1. What is V1? V1 here, the positive side here is directly connected to VA, and the negative one is directly connected to the ground. So V1 here is the positive side, which is VA, and then minus the negative side, which is 0. Okay, so we will have VA. So V1 is equal to VA, and VA is 60 volt. So I will have V1 is equal to 60 volt. So we get our first value here, which is 60 volt. Good. And then what is V2? V2, using the same logic here, V2, the positive side is directly connected to VB, right? And then the negative side here is directly connected to the ground. So I will have VB, the positive side, and then the negative side is the ground, so I'll have minus 0. And so I will have VB here. So we will have V2 is equal to 10 volt. Good, so that is our second value. I will have 10 volt here. So for the voltages, I got 60 volt and also 10 volt. Okay. Now we need to find out what is I1. Is I1? Okay, let's see here. I1 is the voltage the current comes from VA. So we will have VA. And then the current goes to VB. So I'll have VB here. But this is voltage. We need to divide it by the resistance between them. So I will have 5 ohm here. And VA here is 60, right? So I have 60. And VB is 10. So I have minus 10 divided by 5. 60 and 60 minus 10 will be 50. 50 divided by 5. So I will have 50 divided by 5 is 10, right? So I will have 10 ampere. And that is the last value. So we will have 10 ampere there. Okay, 10 ampere. And we finally achieve our goal here. V1 is 60 volt, V2 is 10 volt, and I1 is 10 ampere. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.